Hey, what is up guys? Welcome back to another video, and in this video we're going to be continuing on with our Swift programming tutorial series. And in this particular tutorial we are going to be taking a look at a practical use for generics, where we're going to learn how to create a generic structure. I'm going to explain how this also applies to generic classes. And we're going to create a generic function outside of this generic structure, so you can kind of get an idea of what just a standalone generic function looks like. All right. So what is this practical example we're going to use with a generic structure? Well, we're going to take a look at how we can build our own custom collection using Swift. We're going to build a stack. I already have a stack.swift file loaded into Xcode, and we're going to create a structure called stack. This is going to be a generic structure, and by the end of this particular example, we'll be able to create our own generic stack collection object and reference its elements by their index using the same syntax that we would when we reference the an element in an array. So let's go ahead and get started. In Xcode, what I want you to do is to create a structure called stack. After the name of our structure, we're going to do a less than, t greater than, and then open up the body of our stack. All right, so here we are. Now we're going to create a private variable that's going to hold the items of our stack, and this is going to be an array. So private var, I'm going to call it underscore items. This is going to be an array of generic type t. So when we create our object for our stack and we say this is going to be a stack of ints, the internal array will be an array of integers, and so on and so forth. We're going to set this equal to an empty array by default. Next, we need to have the ability to actually reference our indices by, or rather our elements by their index. And we do this using what's called a subscript. So how does this work? Well, we type the keyword subscript, and then we have left and right parentheses. Inside of the parentheses, we're going to say index :int. This is going to return an optional type t. Inside of the body for this subscript, we need to guard against out of bounds index values. So to do that, we can say guard let, or rather guard, we want guard index less than 0. All right, comma, index is greater than or equal to the underscore items dot count. All right. Else return nil. All right. All right. So now that we're protected against invalid index values, so we're protected against anything that's less than 0 and anything that's greater than or equal to the number of elements currently in our items array. Once we do that, we want to return items index, like that. We want to return the value at the given index from our items array. All right, so there we go. All right. So next we can add in a couple of our methods where we can say mutating func push underscore new element of type T underscore items dot append new element, and then we can say mutating func pop. This will return an optional type T as well. And we can say underscore items dot pop last. We can return like that. All right. Okay. So we can say, I guess, let's try removing mutating. Maybe that'll... No? Let's see, we want... let's see there. Is that working? Yes, it is. Okay, so pop last has to be a method, not a value. I don't know why Xcode did not put in the parentheses, but it didn't. There we go. We fixed our error now. And now we can also, we're going to add one more method, and that is to get the specific element at the index. So we can say func, let's say get at int or at index int. This will also return an optional T. And we can say guard index is less than 0, or rather greater than or equal to 0, index is greater than, or rather less than, the items.counts let's see. We want else return nil. Otherwise, we will return the items index, like that. Now, let's go ahead and take a look again at our subscript, just to make sure that we did this right. Yes, we did do this wrong. So we'll do greater than or equal to 0. Index is greater than or equal to, so we want less than the count of our items. Do one last check. Okay. Okay, yep, we're good. There. Now we have our custom stack. Let's go into our main file and see how this works. So let's go into our navigator. Main. All right. Let's go ahead now and create a stack object. So we'll say var a equals stack less than, and let's say it's a stack of integers. So there's our stack object. What we now want to do is we can say a dot push new element, and this will be a 1, a dot push 2, a dot push 3. All right, and so now we can also loop through our array by saying for index in 0 dot less than, it'll be, we do not have a count property for this, but we can just say 3 for now. So we can say then print index. Save this, run our code, and let's go into our debug area, into our console. We can see 0, 1, 2, So we have our indexes. That worked. And instead, we can say a index, like that. Let's go ahead and do a save and run our code. And in our console, you can see we have optional 1, optional 2, optional 3. So we can go ahead and unwrap these, but you get the idea. So when you try to reference an item, it'll return an optional because you don't know, you might not know. Well, okay. That I should probably reword that a little bit better. The reason why the subscript returns an optional is because you don't know, right, if the index is going to be out of bounds. And that's why we tested to make sure. In our stack structure, we went and made sure that if indeed the index is above the maximum count of elements or below 0, then it'll return nil. All right, so let's go ahead and take a look at that. What we can do is instead of doing our for loop here, we can say let's say 5 as our index. We can try to print that, save it, run it. And when we go into our console, you can see we get nil because there isn't a fourth index. Like there isn't a fourth value in there. Or rather a sixth value, I should say. There isn't a sixth value, there's only 3. So therefore we're printing nil to our console. So with that, I'm going to leave you to add in the count property to this custom stack. Let's go ahead and take a look now at a standalone generic method or function, so you can have an idea of what that syntax will look like. Okay, so to create a generic function with a type parameter of t, no constraints, nothing like that, we can do something like this. Func print object or rather print object or value. Right, so this is what a normal function would look like. But before our parentheses, we need to give it the generic type parameter. So less than, t, greater than. All right. And inside of our parameters, we can say object, and that's going to be of type T. And now we can just say print object. Save our code. And when we call this method, so print object or value, or value. Okay, let's try this again here. Okay. Okay, let's try that again. Print object or value. So now this will take in it'll basically take in anything. We can say 1, 2, 3, 4. We can say print object or value. We can say this is a string. We can say print object or value. We can say stack string. Like that. Save, run it. Now we got a build failed. Why is this? Okay. Okay. All right. Now we are getting an error somewhere. Okay. There we go. Now let's try to build and run it. There we go. Go into our debug area. Console. And now we can see we get 1,234. This is a string. And we get our stack object printed in our console. So that is a generic method. You can generally you'll find methods like this in for example when you're doing network requests and they are generally done the exact same way every time. You're not going to want to rewrite the same code over and over and over again. for different like API endpoints or whatever. So a generic function might be a good choice for that. I know I generally do this. Now, you don't have to do it that way, but you can. So that pretty much does it for this video, guys. Thank you all so very much for watching, and we'll see you in the next one.